Hello and welcome to my walkthrough of the Pearson Edexcel GCSE June 2024 Mathematics Paper 2 Calculator Paper, higher tier. Let's jump straight into it. Question number 1. ABC is a right-angled triangle. Work out the length of CB. Give your answer correct to 3 significant figures. So we can just work this out using Pythagoras. So AB squared plus BC squared is going to equal AC squared. We have AC squared, which is 19 squared. We have AB squared, which is 10 squared. And we can use these to work out BC squared. So 10 squared is just 100. 19 squared, which I'll just do on my calculator, is 361. Therefore, BC squared is 261. Therefore, BC, which is the same as CB, it's they're calling it in the question. I'll do it on my calculator. Square root of 261 is just 16.155. And the question wants it in 3 significant figures. So our answer is going to be 16.2. Question number 2. Write 90 as a product of its prime factors. So 90 is just 3 times 30. 3 is prime, so we don't need to do anything else on that branch. 30 is 3 times 10. 3 is prime, so we don't need to do anything else. And 10 is 2 times 5. Both of these are prime. So our answer is 2 times 3 times 3 times 5. A equals 2 squared times 3, B equals 2 times 3 squared. Write down the lowest common multiple of A and B. So to do that, we just need to work out which numbers are in, well, all of these together, basically. So these, A is 2 times 2 times 3, B is 2 times 3 times 3. So we just have to combine these so that we have every single one. So there's 2 2's in this one, there's 2 3's in this one, so 2 times 2 times 3 times 3, which is just going to be 2 times 2 is 4, times 3 is 12, times 3 again is 36. Question 3. The number of hours H that some machines take to make 5,000 bottles is given by H equals 72 over N, where N is the number of machines. On Monday, 6 machines made 5,000. On Tuesday, 9 machines made 5,000. The machines took more time to make the bottles on Monday than Tuesday. How much more time? So if I say Monday, we have H equals 72 over the number of machines, which is 6, 12 hours. On Tuesday, H equals 72 over the number of machines, which is 9, 8 hours. All we need to do is 12 subtract 8, 4 hours is our answer. Question 4. There are only red discs, blue discs, and yellow discs in a bag. There are 24 yellow discs in the bag. Mel is going to take at random a disc from the bag. The probability that the disc will be yellow is 0.16. Number of red discs compared to the number of blue discs is 5:4 ratio. Work out the number of red discs in the bag. So we have 24 yellow at a probability of 0.16. So if we do 24 divided by 0.16, this gives us the total number of discs. I'll do that on my calculator. 24 divided 0.16 gives us 150. That's all the discs in the bag. So then we can take away 24 to give us total number of blue plus red discs. We have the ratio up here of 5:4, which means 5/9 are red and 4/9 are blue of red plus blue discs. We want the number of red discs, so we're going to do 5 out of 9 times 126, which is the remaining number of discs. Again, do this on my calculator. I get 70 red discs in the bag. Question 5. Complete the table of values for y equals x squared minus x. For minus 1, x squared is just going to be 1, minus 1 is add 1, so that's going to be 2. When x is 1, 1 squared is 1, minus 1 is going to give us 0. And for 3, 3 squared is 9, minus 3 just gives us 6. Part B. On the grid, draw the graph of y equals x squared minus x for values of x from minus 2 to 3. So we've got minus 2 on the x-axis and 6 on the y. we've got -1 and 2, we've got 0, 0, we've got 1, 0, we've got 2, 2, and we've got 3, 6. I'll do my best to draw this freehand on the iPad. Let's try. It's just going to dip under there, and there you go. Part C. Use your graph to find estimates for the solution of the equation x squared minus x equals 4. This is going to be where y equals 4, so let's just do a dotted line at y equals 4. These are our two solutions here. So we'll just read the graph down. That's about -1.5, and the one on the right is about 2.6. The mark scheme gives a little bit of leeway based on how you've drawn your diagram. Question 6. Andy, Luke, and Tina share sweets in the ratio 1:6:14. Tina gives 3/7 of her sweets to Andy. Tina then gives 12.5% of the rest of her sweets to Luke. Tina says, now all three of us have the same number of sweets. Is Tina correct? You must show how you get your answer. So if we have a ratio of 1:6:14, that means Andy had 1 out of 1 plus 6 plus 14, which is 21. Luke had 6 out of 21. And Tina had 14 out of 21. So, for the Andy gifting of sweets, Tina had 14 out of 21. She gives 3/7 of her sweets to Andy, which I'm just going to do on my calculator. So 14 out of 21 times 3 out of 7 just gives me 2 out of 7. And then Tina will be left with 14 out of 21 minus 2 out of 7, which is going to be the same as saying that's 6 out of 21. So 14 out of 21 minus 6 out of 21 leaves her with 8 out of 21 sweets. And then Andy will have 1 out of 21 plus 6 out of 21, giving him 7 out of 21. Then she gives 12.5% of the rest of her sweets to Luke. 12.5% is the same as 1/8. So the rest of her sweets, so she has 8 out of 21, times by 1/8 is 1 out of 21. Therefore, Luke ends up with 6 out of 21 plus 1 out of 21. He has 7 out of 21 now. Tina ends up with 8 out of 21 minus 1 out of 21. She ends up with 7 out of 21. And Andy has 7 out of 21 from the first part of the question. So, is Tina correct? Yes, she is correct. Question 7. ABCD is a quadrilateral. All angles are measured in degrees. Show that ABCD is a trapezium. In order to be a trapezium, these two angles and these two angles both must add up to 180 degrees. It's a quadrilateral, so we know that all four angles added together add up to 360 degrees. So I'm going to use that to get my answer. So I'm going to say 2x plus 15 plus 4x plus 15 plus 4x plus 8 plus 3x minus 3 equals 360. I'm going to put all the x's together. That's going to give us 13x. All the numbers together gives us 35. We'll now take the 35 onto the other side. And then we're going to divide 325 by 13. And therefore we get x equals 25. Now we'll do a check. Angle A is going to be 65. Angle B is going to be 115. A plus B is 180, which we wanted. Angle C is going to be 108. And angle D is going to be 72. C plus D is 180, which is also what we wanted. Therefore, ABCD is a trapezium. Question number 8. A playground is in the shape of a right-angled triangle. Dan makes a scale drawing of the playground. He uses a scale of 1 centimeter representing 5 meters. The area of the playground on the scale drawing is 28 centimeters squared. The real length of QR is 40 meters. Work out the real length of PQ. So if QR is 40 meters, we know that 1 centimeter represents 5 meters. So this must be 8 centimeters. We know the area is 28, so that's going to be half of 8, so QR, times PQ, which is what we're trying to find out. And we know this is 28. So if I do 28 divided by half divided by 8, we know that PQ equals 7 centimetres. Therefore, the real length is just going to be 5 times this and change into metres, as that's our scale, 35 metres. Question 9. A number n is rounded to two significant figures. The result is 7.3. Write down the least possible value of n. That will just be the lowest number that gets rounded up to 7.3, which is 7.25. Layla says the value of n cannot be greater than 7.349 because 7.350 would round up to 7.4. Is she correct? No. N could be 7.3491. It's not specified that it's 3 decimal places. So you could have as many numbers after that as possible that are still less than 7.350. Question number 10. The diagram shows 2 right-angled triangles. All lengths are measured in centimetres. Given that sine A equals tan B, work out the value of x. Sine A is going to be your opposite over your hypotenuse. So your opposite angle is opposite the angle, 7 minus 2x. Your hypotenuse is given to you as 8. Tan B is going to be your opposite the angle, 1 plus x, over your adjacent. And we are told they equal each other. So 7 minus 2x over 8 equals 1 plus x over 4. Multiply the denominators by both sides gives us 4 lots of 7 minus 2x equals 8 lots of 1 plus x. Expand it out. Add 8x to both sides. Take the 8 onto the other side. Gives us 20 equals 16x. Therefore, x equals 20 over 16, which is the same as 1.25. Just check that on my calculator. Yeah, that's right, 1.25. Question 11. The frequency table gives information about the weights of 60 parcels. Complete the cumulative frequency table. This one's nice and easy. All you need to do is add the frequencies up so that they accumulate. So 7, then 7 plus 21 is 28. Add 15 is 43. Add 11 is 54. And add 6 is 60. Part B. On the grid opposite, draw a cumulative frequency graph for your table. So all we need here is for each weight, we need to draw dots on here. So for 2 kilograms, we're going to have this at 7, which is here. Then for 4 kilograms, we're going to have 28 up here. 6 kilograms, we're going to have 43. And then we have 8 kilograms for 54. 8, 54. And then lastly, we have 10 for 60. And we're going to draw a nice smooth curve, just like that. Part C. Use your graph to find an estimate for the interquartile range. So the lower quartile is going to be a quarter of the overall number, so that's going to be the 15th term, which is just going to be here, roughly, which sits at 2.8 on the way I've drawn this. And then the upper quartile is going to be the 45th, as it's the 3/4 of the 60. 45 is up here somewhere. It's between these two squares for me here. So that's going to be 6.15, I think I have it as, if I've read that correctly. No, I haven't. That's between 6.2 and 6.4. So we're going to go with 6.15. 3. So my interquartile range is going to be the distance between the two of them, which I got as 3.5 kilograms. On the mark scheme, it lets you have between 3.4 and 4. Part D, use your graph to find an estimate for the number of these parcels with a weight greater than 7.4. So we'll find 7.4, which is here, follow the line all the way up to about here, and that is 51 and above. So our answer is just going to be 9 parcels, as it only goes up to 60. And that's our answer. Question 12. F is inversely proportional to d squared. F equals 3.5 when d equals 8. Find an equation for f in terms of d. So f being inversely proportional means there'll be k, a number, which runs the proportion. So if we put in f and d from our numbers over here, we have 3.5 equals k over 8 squared, which is 64. Then I'm going to multiply 64 onto the other side. I'll use my calculator for this. 3.5 times 64 gives 224. And let's just put 224 into our equation. F equals 224 over d squared. And that is our equation. Part B, find the positive value of d when f equals 10. Give your answer correct to 3 significant figures. So 10 equals 224 over d squared. Therefore, 10d squared equals 224. Therefore, d squared equals 224 divided by 10, which is obviously just 22.4. Therefore, d equals, here's on my calculator, square root of 22.4, 4.73, as it wants it to 3 significant figures. Question 13. On the grid, shade the region R that satisfies all the following inequalities. So, x is less than or equal to 2. So I will draw the line. I don't have a ruler here. You would use a ruler for your exam. Absolutely. I'm just on an iPad, so I can't use a ruler. This is the line of x equals 2. So it's going to be everything on the left of that. That also falls in y is greater than or equal to minus 3, which is this line here. Everything above that, sorry, it gets a little bit more complicated. Y is less than or equal to 2x plus 1. So for the line, to work out this line, when y equals 0, I'll just do it on here, 0 equals 2x plus 1. We'll take the 1 onto the other side, so minus 1 equals 2x. X would equal minus a half. So when y equals 0, x equals minus a half. So that's going to be about here. So that's going to be about here. And then when x equals 0, we're going to have y equals 1. So that's just going to be here. And we know it's a straight line. So we're just going to draw it through roughly here, like that. And the last one, 3x plus 2y is less than or equal to 6. In a similar way, when x is 0, we're going to have y is 3. So x is 0, y is 3. And when y is 0, x is going to be 2. That's here. It's a straight line. So we're going to go like, whoops, it's a bit dodgy drawing there. But we need to make sure it's to the left of this line, above this line, and then what have we got? Less than or equal to 2x plus 1. So we need it to be below this line, and we need it to be below this line. So our region is going to be this region here that I will label R. Question 14. The graph shows the velocity of a car in meters per second, t seconds after it starts to slow down. Calculate an estimate for the acceleration of the car when t equals 5. you must show all your working. So t equals 5, we're going to have to draw a tangent here. So 5 is here. Again, I do not have a ruler, so this makes this very tricky. We'll go with that. And this is just going to be a bit of an estimate, but I'll follow the line all the way down to here just to make it a bit more obvious. dy dx to work out the gradient of the tangent. We go from this point here down to this point here. So difference in y goes from 20 to 0, so that's 20. Difference in x goes from 7 to 0, so that's 7. But it's, of course, minus. So we get, just on my calculator, 20 over 7. I've got 2.9 as my answer. But I'm fully aware that the mark scheme has got this as a range again. So provided your drawing has been done with a ruler, you'll get an actual decent answer here. So 2.8 is the minus 2.8 is the answer that we have in here. So I'm very close considering I've got no ruler, but that's how you do it. Question B, part B. Work out an estimate for the distance the car travels in the first 6 seconds after it starts to slow down. Use 3 strips of equal width. We're going to need to use a trapezium rule here. So what I'm going to do is I'm going to say V0, the first point, is going to be 25, which is our very first line up here. Then we want the first 6 seconds as 3 strips, so we want 2, we want 4, and we want 6. So at 2, we have 17. At 4, we have, what's that, 9? That's not 17, that's 16, isn't it? At 4, we've got 9. And at 6, we've got, that looks like 4 to me. So what I'm going to do is go down. V2, 16, V4, 9, V6, 4. And what I need to do is say distance equals h over 2 multiplied by 25 plus 2 lots of 16 plus 2 lots of 9 plus 4. H in our scenario is just 2, so that becomes 2 over 2, which is just 1. So we get 25 plus 32 plus 18 plus 4, and therefore our answer is just 57 plus 19, plus 22, gives you 79. Question 15. Given that a is a prime number, rationalise the denominator of 1 over square root of a plus 1. You just do this by multiplying top and bottom by the square root of a minus 1. So that gives us square root of a minus 1 over square root of a plus 1, square root of a minus 1. Root a times root a gives you a. 1 times root a is root a, minus 1 times root a is minus root a, so they cancel. Minus 1 times 1 is just minus 1. So that's our answer, square root of a minus 1 over a minus 1, and that's as simple as you can write that. 16. Solve 4x minus 3x plus 5 is less than 0. It's a nice easy one. You've got critical values here of x equals minus 5, as we basically take it that this one here equals 0, or this one here equals 0, to get the critical points. So that one's x equals minus 5, this one's x equals 3/4. And we want to know at what solutions the equation is less than 0. So we just have when x is between minus 5 and 3/4, You can test this by saying x equals 6 to test whether you want this to be less than or greater than 5. So when x equals 6, we get 24 minus 3 is 21, multiplied by 11. Minus 6, of course it is. When x equals minus 6, we get minus 24 minus 3 is minus 27. Minus 6 times minus 6 plus 5 gives minus 1. Multiply them together, you get a positive number. So it has to be greater than minus 5. And the same thing you can do for the 3/4. Question 17. L, M, and P are three similar solid cylinders made from the same material. L has a mass of 64, M has a mass of 125, M has a total surface area of 144, P has a total surface area of 16. Work out the height of cylinder L compared to the height of cylinder M compared to the height of cylinder P. This is a question all about ratios. So if L and M are similar, we know that the cube root the cube root of 64 compared to the cube root of 125 will show us the ratio of the heights. So the cube root of 64 is just 4, and the cube root of 125 is just 5. So that is the ratio for height between, L and M. And in a completely similar way, the square root of 144, because this is the surface area, so we have the mass up here, now we're looking at the surface area, compared to the square root of 16, is going to give us, again, the ratio for height. This is going to be 12, this is going to be 4, ratio for height of M and P. But we want L to M to P. So we currently have L to M and M to P, and you can see that the M here is represented by a 5 and the M here is represented by a 12. So what we need to do is get them to be one and the same. So first thing I'm going to do is simplify this bottom one, because I can divide both sides by 3. So I'm going to say this by 4 even. It's going to say this is 3 compared to 1. So now we're comparing 4 to 5 and 3 to 1. So instead of writing this as 4 to 5, what I'm going to do is write this as 12 to 15. And I'm going to write this as 15 to 5. So all I've done here is I've multiplied this one by 3 for both sides, and I've multiplied this one by 5. Now we have L to M and M to P, where M is the same number in both ratios, which allows me to write L to M to P as 1 ratio. And that is our answer. Question 18. There are only 4 red counters, 3 yellow counters, and 1 green counter in a bag. Tony takes at random 3 counters from the bag. Work out the probability that there are now more yellow counters than red counters in the bag. You must show all your working. So, first thing to notice here is if 1 yellow gets taken, there will never be more red than yellow at the end. Now, what I mean by that is since you start with 4 red, if you take 1 yellow here, you end up with 2 yellows. At best, you take 2 more reds, you still only end up with 2 reds. So it's not more than the 2 that you had at the start. So our scenarios have to be when you don't take a yellow one at all. So your options are red, 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 green, red, 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 green, green, red, red. That is the only scenarios where this can happen. So, probability of this happening, so probability of red, red, red is going to be 4 out of 8 multiplied by 3 out of 7, as 1 red's now gone, multiplied by 2 out of 6. This one's going to be 4 out of 8 multiplied by 1 out of 7 multiplied by 3 out of 6. This one's going to be 4 out of 8 multiplied by 3 out of 7 multiplied by 1 out of 6. And this one's going to be 1 out of 8 multiplied by 4 out of 7 multiplied by 3 out of 6. So we can now work all these out, add them together, and that should be our probability. So 4 out of 8 multiplied by 3 out of 7 multiplied by 2 out of 6. Just doing this on my calculator. That's 1 out of 14. Then we have 4 out of 8 multiplied by 1 out of 7 multiplied by 3 out of 6 is 1 out of 28. 4 out of 8 multiplied by 3 out of 7 multiplied by 1 out of 6 is 1 out of 28. And we have 1 out of 8 multiplied by 4 out of 7 multiplied by 3 out of 6. That's 1 out of 28. Therefore, total probability is, we can just rewrite this as 2 out of 28 to make this a bit easier. That's going to be 5 out of 28. And that is our answer. Question 19. The diagram shows quadrilateral OACB. M is the midpoint of OA. N is the point on BC such that BN compared to NC is 4 compared to 5. OA equals A, OB equals B, AC equals KB, where K is a positive integer. Express MN in terms of K, A, and B. Give your answer in the simplest form. So MN, if we were to follow the trail around, is going to be MO, this bit, plus OB, this bit, plus BN, this bit. Now, MO is halfway between OA, so that's going to be half of small a. OB is B, we're told that. BN's a difficult one. We've got this, so 4/9 of BC is BN, and then 5/9 is NC. So we're going to say this is 4/9 of BC, but what's BC? So BC is the same as BO plus OA plus OC. So all I've done there is gone the long way around this, like this. So BO is the opposite of OB, so that's minus B. OA, we already have, is A. And OC, sorry, I don't mean OC, do I? I mean AC. AC is KB. Therefore, MN equals a half A plus B plus 4/9 of minus B plus A plus KB. Of course, they want us to give this in its simplest form, so we're going to say this is a half A plus B minus 4/9 B plus 4/9 A plus 4K over 9B. In terms of simplest form, what I'm going to do is I'm going to do all of this as 18ths. So this is now going to be 1/18 lots of 9A plus 18B minus 8B plus 8A plus 8KB. I've just spotted I've got something the wrong way around here. So at the very, very start, where I said MN equals MO over here, MO is indeed half of the length between O and A, but it is going in the opposite direction, so this should be a minus a half A. So just updating that over here, like that, there we go. Easy to make mistakes on signs for things like this, so always check your work. So this should be minus A plus 10B plus 8KB, and that is our final answer. Said very fiddly this with the directions of your vectors. 8KB. Is MN parallel to OB? In order for it to be parallel, it needs to be a multiple of B, as OB is B. But there's A's in here, so no. not parallel, not a multiple of b. Question number 20. The curve C has equation y equals 2x squared minus 12x plus 7. Find the coordinates of the turning point on C. So we're going to complete the square here. So what we're going to do is y equals 2 lots of x squared minus 6x plus 7, which of course can be rewritten as 2 lots of x minus 3 squared minus 9 plus 7, which is just 2 lots of x minus 3 squared minus 11, as we've got the minus 9 times the 2 is your minus 18 plus the 7. Therefore, minimum happens when x equals 3, and when x equals 3, this will all disappear, and you'll just be left with y equals minus 11. So your turning point is just going to be 3 minus 11. Question 21. The graph of g of x is shown on the grid. On the grid, draw the graph of g of minus x plus 2. So all we have to do on this one is flip the graph y equals g of x, or rather reflect it in the y-axis, and then shift it up 2 units. An easier way to look at it is that, all right, I might even write this down. If you've got y equals g of x, every point that was xy goes to minus x, y plus 2, for y of g of minus x plus 2. So, for example, if we look at this point here, this is minus 1, 1 on the original graph, which means this point's going to go to 1 on the x-axis, 3 on the y-axis. Similarly, if I look at this point here, 1 minus 2 is going to go to minus 1, 0. It's completely flipped. And then lastly, I'll look at this one. We've got 3, 1 is going to go to minus 3, 3. Now I've got these 3 points. We can draw the curve, which I'll try and do my best on. So it's shifted up 2 spots and it's been reflected in the y-axis. And the final question on the paper. Question 22. A and B are points on a circle, centre O. MAP and NBP are tangents to the circle. Prove that AP equals BP. So, OA, which I'll draw here, we know is perpendicular to MP, because a radius is perpendicular to the tangent at the point of contact, and this is the same here. Then what we're going to do is draw a line to OP, it's supposed to be a straight line, to make 2 triangles, this one and this one. We know that that's 90 degrees if we've already drawn it over here and down here. We know that OA and OB are equal because they're both the radius of the circle. And we know that OP in both of these 2 triangles is the same line. Let's call it Y. Now, we have 2 triangles where 2 sides and an angle are the same. So, in fact, it's the hypotenuse as well. So I'm going to say, so we have 2 triangles, OAP and OBP, where 2 sides, including hypotenuse, and an angle, are the same. Therefore, by definition of the triangles, the third side must be congruent. Must be the same, in fact, I'm going to put. Therefore, the third side in these scenarios is this line here and this line here. So therefore, AP equals BP as required. And that's the end of the paper. As ever, thanks for watching. Leave a comment below if you've got any questions or queries or anything, or comments, and I will catch you next time.